In the quiet corner of a room, a nearly invisible thread of silk hangs in the air, holding the weight of a small creature with 8 legs. For some, this sight is unsettling enough to cause fear or panic. Yet behind that fragile line of silk lies one of the most extraordinary survival stories in the natural world. Spiders have existed for more than 380 million years long before humans ever walked the earth. Over that vast stretch of time, they have evolved into one of the most efficient and adaptable predators on the planet. Today, scientists have identified more than 45,000 species of spiders spread across nearly every corner of the globe. From dense tropical rainforests and arid deserts to frozen mountain slopes and even the hidden corners of human homes. Spiders have found ways to thrive in environments that seem almost impossible to survive. Unlike insects, spiders belong to a separate class called arachnids. They do not have wings, and their bodies are supported by an external skeleton. Their 8 legs, finely tuned sensory organs, and unique ability to produce silk have made them masters of survival. Some use silk to spin intricate webs, while others weave trapdoors in the ground or coat their burrows with silk for stability. There are species that hunt directly on water using tiny water-repellent hairs to move across the surface, while others lie hidden beneath sand, waiting to ambush unsuspecting prey. The power of a spider lies not only in its speed or venom, but also in the way it grows, adapts, and transforms through its life cycle. From a fragile egg encased in silk to a fierce hunter capable of building vast webs or ambushing prey with surgical precision, the story of a spider's growth is a story of resilience and survival. Spiders also play a critical role in the balance of ecosystems. Each year, they consume hundreds of millions of tons of insects, keeping populations of flies, mosquitoes, and countless other pests under control. Without spiders, the explosion of insect numbers would reshape entire environments and make human life far more difficult. In this way, spiders are not only feared predators, but also unsung guardians of balance in the natural world. The journey of a spider begins in a place that seems insignificant, almost invisible. Hidden inside a delicate sack of silk, new life is protected from the dangers of the outside world. It is there in the quiet safety of this cocoon that the cycle of survival begins. From that fragile starting point, the spider will undergo a transformation marked by growth, struggle, and astonishing adaptations. Each stage of its life reveals new strategies, new survival skills, and new ways of mastering the challenges of the environment. The path from egg to adulthood is not only a biological process, but also a reflection of nature's relentless creativity. And so the story of the spider begins not with fear or menace, but with resilience and the will to survive. It is a story that unfolds step by step from the moment a single egg is laid to the rise of one of the most extraordinary hunters on Earth. Every spider's journey begins in silence, long before a single thread is spun into a web, before legs move across branches or walls. The story starts within a carefully woven sack of silk. For the mother spider, creating this protective chamber is an act of both instinct and precision. She produces silk from her spinnerets, layering it into a dense cushion-like envelope, and then deposits her eggs inside. The number of eggs varies greatly depending on the species. Some females lay just a few dozen, while others can deposit hundreds, even thousands, within a single sac. This egg sac is more than just a container. It is a fortress. The silk acts as a barrier against parasites, predators, and the harsh elements of the environment. In deserts, the sac shields the fragile eggs from scorching heat and dryness. In rainforests, it protects them from moisture and mold. For ground-dwelling spiders, the sac may be buried under soil or tucked beneath leaves hidden from watchful eyes. For web-spinning species, it may hang suspended, swaying gently in the air, just out of reach of ants or other opportunistic intruders. Inside, life stirs in the tiniest forms. The eggs themselves are soft, pale, and nearly translucent. Within days or weeks, depending on the species and the climate, embryonic spiders begin to develop. Their tiny bodies form, each equipped with the fundamental traits they will carry into adulthood: 8 segmented legs, multiple eyes, and the beginnings of silk glands. Though minuscule, these early spiderlings already possess the blueprint of their predatory lineage. The mother's role during this stage can differ dramatically from species to species. Some spiders abandon the sac soon after it is completed, leaving the eggs to survive on their own. Others guard the sac fiercely, carrying it attached to their abdomen, never letting it out of sight. Wolf spiders are known for this level of dedication, keeping the egg sac close until the spiderlings hatch and then allowing them to climb onto the female's back for protection. In these moments, the fierce predator becomes a caretaker, ensuring her young have the best possible chance of survival. Even with such care, the egg stage is one of the most dangerous points in a spider's life. For every sac that survives, countless others are destroyed. Parasitic wasps may inject their own eggs into the sac, turning the developing spiderlings into hosts for their larvae. Ants and beetles may chew through the silk, devouring the eggs inside. Environmental conditions can also be unforgiving. A sudden frost, excessive rain, or lack of humidity can doom hundreds of unborn spiders before they ever take their first steps. Yet the persistence of the species is remarkable. Spiders have evolved strategies to counter these threats. Some produce multiple sacs over a single breeding season, spreading the risk across different locations. Others weave their sacs with particularly tough silk, nearly impenetrable to most predators. Some even disguise their sacs with debris, dirt, or bits of leaves, camouflaging them from plain sight. As development progresses, the spiderlings inside the sac grow restless. They shift, wriggle, and test the limits of the silk barrier surrounding them. When the time is right, they break free, sometimes in a coordinated burst. For an observer, this can appear like a cloud of tiny creatures suddenly spilling into the world, each one smaller than the head of a pin, but alive with instinct. These newly hatched spiderlings are delicate, their bodies soft and pale. At first, they cluster together near the remains of the sac, often staying close for safety. But instinct quickly takes over. Many species disperse almost immediately, using one of the most extraordinary behaviors in the spider world, ballooning. A spiderling climbs to an elevated position, raises its abdomen, and releases a thread of silk. Carried by the wind, it lifts into the air and drifts away, sometimes traveling only a few feet, sometimes soaring for miles. This is nature's solution to competition. By scattering widely, the young spiders reduce the chance of overwhelming each other in a single location and increase the odds that at least some will find suitable habitats to survive. Ballooning has allowed spiders to colonize places few creatures their size could reach. Islands, mountaintops, and even remote corners of human homes are often settled by spiderlings born on the wind. Scientists have even recorded ballooning spiders landing on ships far out at sea, evidence of just how effective this dispersal method can be. For the spiderlings, however, dispersal is only the beginning. They emerge into a world filled with dangers. Birds, lizards, amphibians, and even other spiders view them as easy prey. Food is scarce, and the spiderlings themselves may turn to cannibalism, devouring weaker siblings in their struggle to survive. This harsh reality ensures that only the strongest and most resourceful continue the journey. The egg stage and the immediate period following hatching sets the foundation for the spider's entire life. Those that survive the perils of this fragile beginning carry forward into the next critical phase of their growth, the molting stage. In this stage, they will face the challenge of outgrowing their own bodies, shedding their exoskeletons again and again as they rise toward maturity. The cycle of survival is unforgiving. From the safety of the egg sac to the uncertainty of ballooning into the unknown, each spider carries with it the legacy of millions of years of adaptation. The fragile egg, so easily overlooked, holds within it the blueprint of one of nature's most successful predators. The spiderling that drifts down from the air or crawls away from its egg sac is fragile, but it already carries the most defining feature of its life, a body bound by an exoskeleton. Unlike humans who grow steadily within flexible skin, a spider's body is encased in a hard outer shell. This shell, called the exoskeleton, provides protection and support, but it has one severe limitation. It cannot expand. The spiderling inside may feed and grow, but at some point the rigid casing becomes too tight. For a spider to continue living, it must perform one of the most dangerous feats of its life. It must molt. Molting is a process of transformation that occurs repeatedly during a spider's development. Each molt is both an opportunity and a risk. To shed its old exoskeleton, the spider first prepares itself internally. Fluid builds up within its body, creating pressure against the hardened shell. The exoskeleton begins to crack along preformed lines, usually near the cephalothorax, the fused head and thorax of the spider. The spider then pushes, writhes, and slowly extracts itself from the old casing, pulling free each leg, each joint, and its entire abdomen. When the spider emerges, it is soft and pale, a vulnerable version of itself. In this brief state, its new exoskeleton is pliable and unprotected, leaving the spider defenseless against predators. Even the pressure of its own weight or the struggle of walking can be dangerous during these hours. It waits hidden in safety if possible until the new shell hardens and darkens, restoring strength and structure. Only then does it resume the rhythm of hunting and survival. This cycle repeats itself many times. A small spiderling may molt 5 to 10 times before reaching adulthood. Each molt brings growth but also subtle changes in form and capability. The body becomes larger, the colors more distinct, and the legs more powerful. In some species, molting is also the moment when striking patterns emerge, the camouflage of sand spiders or the vivid hues of orb weavers becoming more pronounced as they mature. For males and females, molting often marks the transition into reproductive readiness, a point at which their lives take very different paths. The dangers of molting cannot be overstated. A spider may fail to fully emerge, leaving a leg trapped within the old exoskeleton. In such cases, the limb may be lost entirely. For some species, this loss is not fatal. They can continue living with fewer legs, adapting their hunting strategies to their diminished form. Others may not survive the trauma at all. Weakness during molting also makes spiders prime targets. Ants, wasps, and larger predators often strike at these moments of vulnerability when the spider's natural defenses are stripped away. Yet molting is not only about survival, it is about unlocking the potential for growth. Each shed exoskeleton represents progress, a step toward a fully developed predator. The process even allows for the repair of injuries. A spider that has lost a smaller leg in its youth may partially regenerate the limb in subsequent molts, regaining some of its lost mobility. Nature in this way grants spiders resilience, a second chance written into their biology. For many species, molting is tied closely to their hunting strategies. The orb weaver that relies on vast symmetrical webs must grow to a size capable of producing the silk structures that define its role in the ecosystem. The trapdoor spider, hidden within the earth, needs powerful legs and jaws to burst from its burrow with speed and force. The fishing spider, balanced on the surface of water, requires long legs and the strength to push through resistance. Each of these adaptations comes with growth, and growth comes only through molting. Observing a spider molt is to witness both fragility and strength in a single moment. The old exoskeleton, a hollow husk, remains behind, often still shaped like the spider itself. Next to it, the living creature rests as larger and renewed, as if reborn. For naturalists, these discarded shells provide clues about the spider's age and development. For the spider, they are simply the remains of an old self, a past left behind so that life can continue forward. As the molts accumulate, the spider approaches maturity. For males, this often means their final molt ushers them into the brief chapter of reproduction, after which their lives may be short. For females, maturity signals a longer journey, often measured in years, marked by hunting, web building, and reproduction. The molting stage reveals the delicate balance of life for spiders. It is a cycle of shedding, renewal, and survival, repeated until the creature reaches its final form. Each molt is a gamble, but without it, growth is impossible. The spider's ability to endure this process again and again is a testament to its resilience. From the fragile beginnings in the egg sac through the perilous dispersal of spiderlings, molting stands as the first true test of endurance. It is here that weak individuals often fail and the strong move forward. The survivors of this stage carry the lessons written into their very bodies that to live, one must be willing to break free, to leave behind what no longer fits, and to emerge stronger than before. With each successful molt, the spider inches closer to the stage of full maturity, where its abilities will be tested not only by survival, but by its role in the larger cycle of life. Once adulthood arrives, the spider will face new challenges, finding food, securing territory, and eventually reproducing. And as the cycle continues, the story of one spider becomes part of the unbroken story of its species, stretching back millions of years. After a series of molts, the spider finally emerges into its adult form. Its body is now fully developed, its exoskeleton hardened, its colors vivid or subdued depending on its survival strategy. From this point forward, it will no longer molt. Instead, its life becomes centered on survival, hunting, reproduction, and for many species, constructing the intricate silk structures that define its presence in the ecosystem. Adulthood transforms the spider into a formidable predator. The hunting techniques vary dramatically across species, each shaped by millions of years of adaptation. The orb weaver constructs vast symmetrical webs that gleam in the morning dew, delicate in appearance, but powerful in function. Each strand is laced with microscopic adhesive droplets that trap flying insects. When prey becomes entangled, the spider senses the vibrations along the radial lines and rushes in with precision, immobilizing the struggling victim with silk before delivering venom through its fangs. For spiders that do not rely on webs, adulthood is marked by active pursuit. The wolf spider roams the ground at night, relying on keen eyesight and explosive bursts of speed to ambush insects and small arthropods. The trapdoor spider lies in wait within its camouflage burrow, its door hinged with silk and soil. At the slightest vibration of its trip lines, the spider launches upward with lightning speed, dragging the prey below. The fishing spider, equipped with long legs coated in hydrophobic hairs, hunts along ponds and streams, skimming across the water's surface, or plunging beneath to seize aquatic insects and even small fish. Each of these strategies reflects the diversity of adulthood across spider species. The unifying element, however, is silk. Even those that do not spin, capture webs rely on silk for other purposes. It lines their burrows, secures their eggs, or acts as a lifeline when moving through dangerous terrain. Some species, like the spitting spider, even weaponize their silk-shooting venom-laced strands from their bodies to immobilize prey at a distance. Adulthood is when these behaviors are refined, tested, and perfected in the daily struggle for survival. The adult spider's diet expands compared to its younger stages. Small insects remain staples, but larger adults may take down prey many times their size. A robust orb weaver can subdue moths and grasshoppers. A tarantula may overpower lizards, frogs, or small mammals. Venom plays a central role in this hunting success. Different species produce venoms that range from neurotoxins that paralyze prey instantly to enzymes that liquefy tissue, allowing the spider to consume its catch through external digestion. Vision, too, becomes critical in adulthood, especially for active hunters. Jumping spiders, though small, possess some of the most advanced eyes among arachnids, capable of detailed color vision and depth perception. This allows them to stalk and leap accurately onto prey. Wolf spiders, nocturnal by nature, rely on eyes adapted to low light, reflecting moonlight or starlight, to track their quarry. The diversity of visual adaptations highlights how adulthood is not a single model, but a spectrum of evolutionary solutions. Territoriality and risk also emerge more strongly in this stage. Some spiders fiercely defend their webs or burrows from intruders. Others must contend with their own kind as competition intensifies. Cannibalism is not uncommon, especially in times of scarcity. For adult males, this danger often extends to reproduction. Courtship becomes one of the most delicate dances in the animal kingdom. A male must signal his presence carefully, often through vibrations on a female's web or through specific leg movements to avoid being mistaken for prey. Even with such efforts, many males are attacked and consumed during or after mating, their lives sacrificed in the continuation of the species. For females, adulthood is often a longer chapter. Once fertilized, a female devotes significant energy to producing egg sacs. Depending on the species, she may weave elaborate protective coverings, guard the eggs closely, or even carry them with her until they hatch. In wolf spiders, newly emerged spiderlings ride on the mother's back, a rare display of parental care among arachnids. These behaviors ensure that at least some offspring survive to repeat the cycle, though the mortality rate remains high. Life expectancy in adulthood varies widely. Small house spiders may live only a year, their cycles compressed and brief. Larger tarantulas, especially females, can live decades, enduring long periods without food, surviving droughts, and molting fewer times once maturity is reached. This range reflects the adaptability of spiders to different ecological niches. The presence of venomous species adds a layer of tension to adulthood. Spiders like the black widow or the brown recluse have gained in notoriety for their medically significant bites, though in truth they rarely pose a threat unless provoked. The six-eyed sand spider, one of the most venomous of all, remains so elusive in its desert habitat that human encounters are exceedingly rare. For these species, venom is a tool of survival, not aggression. It serves primarily to subdue prey and deter predators. In adulthood, the spider also reveals its role within larger ecosystems. By controlling insect populations, it prevents outbreaks that could devastate crops, spread disease, or disrupt food chains. Studies estimate that the combined weight of insects consumed by spiders each year surpasses the weight of all humans on Earth. This staggering figure underscores their importance not only as predators, but as regulators of ecological balance. Yet adulthood is not invincible. Birds, reptiles, amphibians, and even mammals hunt spiders. Parasitic wasps lay eggs on or inside them, turning the living spider into a nursery for larvae. Environmental threats from wildfires to urbanization continue to alter habitats and challenge survival. Even so, the resilience of spiders is evident in their persistence. They adapt, find new niches, and continue their life cycle with remarkable consistency. The adult stage represents the culmination of all the risks and struggles endured from egg to spiderling. Each molt, each dispersal, each narrow escape from predators has led to this moment. Now fully grown, the spider stands as both predator and prey, a crucial link in countless food chains. Its role is not static, but dynamic, shaped by the demands of survival and the drive to reproduce. The final act of adulthood is often reproduction itself. For males, this may mean the end of life, their energy expended in a single chance to pass on their genes. For females, it begins the cycle anew as she crafts egg sacs that will contain the next generation. With this act, the adult spider ensures continuity, bridging the past with the future in the unbroken story of arachnid survival. Adulthood for spiders culminates in reproduction, the point where individual survival gives way to the larger survival of the species. Every stage that came before hatching, dispersal, molting, the sharpening of hunting skills leads to this moment. The drive to reproduce is powerful, yet it is also fraught with risks. For many species, courtship is one of the most dangerous acts an adult spider will ever attempt. Males, often smaller and shorter-lived than females, must navigate this challenge with extraordinary care. Approaching a female without the right signals can be fatal. To her, the vibrations of his footsteps across her web might resemble those of struggling prey. In that instant, instinct can take over, and the male becomes a meal instead of a mate. To avoid this, males have evolved elaborate behaviors. They pluck at webs in rhythmic patterns, tap the ground with their legs, or perform dances that display their presence. In jumping spiders, males use flashes of color and precise movements, a choreography intended not only to attract, but also to pacify the larger, more dangerous female. When courtship succeeds, mating occurs in a way that is unique among spiders. Males first prepare by producing a small sheet of silk, depositing sperm onto it, and then drawing the sperm into specialized appendages called pedipalps. These structures allow the male to transfer sperm directly to the female's reproductive organs. It is an intricate and vulnerable process requiring close contact that leaves the male exposed to attack. Even in successful pairings, the male may not survive long afterward. In some species, he is consumed by the female immediately following copulation. While grim from a human perspective, this act provides nourishment to the female energy that may support the development of her eggs. In evolutionary terms, the sacrifice ensures that the male's genetic contribution is carried forward. For females, reproduction marks a new and demanding phase of adulthood. Once fertilized, she begins the process of creating egg sacs. Using her silk, she constructs protective casings tailored to her environment and species. Some are simple spheres, others elaborate structures woven into the architecture of her web or hidden beneath soil and leaf litter. Each sac represents not only her future offspring, but also her investment of time and energy. In some species, females create multiple sacs in succession, each containing dozens or even hundreds of eggs. The act of guarding the egg sac varies. Some females leave the sac hidden and abandon it, trusting the silk and placement to provide sufficient protection. Others exhibit remarkable levels of care. Wolf spiders carry their egg sacs attached to their spinnerets, never letting them go until hatching. When the young emerge, they climb onto the mother's back, where she transports them for days or weeks. This maternal care, rare among arachnids, gives her offspring a higher chance of surviving their fragile early days. Reproduction is not only a matter of individual survival, but of ecological balance. Each egg sac represents hundreds of potential predators that will, if they survive, consume untold numbers of insects. For the environment, this constant renewal of spider populations is a natural form of regulation, preventing insect outbreaks that could devastate plant life, agriculture, and even human health. The cycle, however, is not guaranteed. Most spiderlings will not survive to adulthood. Predation disease and environmental challenges claim the majority long before they have the chance to reproduce. Yet the strategy of producing large numbers of eggs ensures that at least some individuals carry the lineage forward. It is a system of abundance and attrition, a numbers game, that has allowed spiders to thrive for hundreds of millions of years. For some species, reproduction signals the end of the female's life as well. After depositing her eggs, she may weaken her energy, depleted by the effort of laying and guarding. In other cases, females live on producing multiple sacs over their lifespan. The range of possibilities is vast, shaped by environment, climate, and evolutionary history. The legacy of reproduction extends beyond the individual. It is through this act that spiders have spread across every continent except Antarctica. It is why they persist in deserts, jungles, mountains, and homes. Ballooning spiderlings carried by the wind, burrow dwellers hidden beneath soil, web builders suspended between branches, all are part of a continuous story. Each generation, no matter how small or fragile, represents a thread in the vast tapestry of arachnid survival. The continuation of the cycle underscores a deeper truth about spiders. They are not creatures defined solely by fear or menace, but by persistence. From the fragile beginnings within an egg sac through the peril of dispersal and the trials of molting into the complexity of adulthood and the risks of reproduction, the spider embodies resilience. Every stage of its life is a test, and every success adds to the unbroken chain of its species. As the new spiderlings hatch and scatter into the world, the cycle begins again. The mother's role is complete, the father's contribution long finished, but the lineage lives on. What was once a single egg sac hidden beneath a leaf or suspended on a branch has become dozens of new predators, each ready to face the challenges of survival. The story resets, but it is never the same. Each generation carries with it the accumulated history of survival strategies honed over millions of years. In this way, the life of a spider is not just about the individual, but about continuity. It is about the passage of life from one stage to the next, one generation to the next one, environment to the next. It is a reminder that even the smallest and most easily overlooked creatures play roles of immense importance in the balance of the natural world. The journey of the spider from egg to adulthood and back to the laying of eggs is a cycle that never truly ends. It is the quiet heartbeat of ecosystems everywhere, a rhythm of birth, growth, survival, and renewal. It is a cycle that has endured since before the rise of dinosaurs and will likely endure long after humans are gone. The spider so often feared is in truth a symbol of persistence, adaptation, and the unbroken thread of life itself, the life cycle of a spider. In the quiet corners of the world, hidden beneath leaves tucked into crevices or suspended in the air, a thread of silk begins a story. It is a story of survival, adaptation, and transformation carried out for more than 30 million years. It is the story of the spider, one of the most successful predators on the planet. Spiders belong to the class Arachnida, distinct from insects defined by 8 legs, silk-producing spinnerets, and remarkable adaptations that allow them to thrive in nearly every environment on Earth. With more than 45,000 known species spread across forests, deserts, mountains, and homes, spiders are both feared and admired. They are symbols of menace in human imagination, yet essential regulators of ecological balance, consuming hundreds of millions of tons of insects each year. The life of a spider is not measured by sheer existence alone, but by the cycle of transformation it undergoes. From a delicate egg hidden in silk to the emergence of spiderlings, from the repeated trials of molting to the mastery of adulthood, and finally to reproduction and renewal, the spider's journey is one of resilience and persistence. The egg stage, a fragile beginning. Every spider begins life within an egg sac, a protective chamber woven from silk by the mother. The number of eggs varies by species from a few dozen to hundreds, even thousands. The sac itself is a fortress, shielding the developing young from predators, parasites, and environmental extremes. Some sacs are buried underground, others hidden beneath foliage, and some suspended in webs. Inside, embryonic spiders form, already carrying the basic blueprint of their kind. The mother's role during this time differs greatly among species. Some leave the sac behind their duty complete. Others, like wolf spiders, guard the sac fiercely, carrying it with them until hatching. This care increases the chances of survival, but cannot guarantee safety. Parasites may invade predators, may tear open the sac and weather may destroy it. Yet through sheer numbers and resilience, some spiderlings survive to emerge. When the time comes, the tiny young break free, clustering briefly before dispersing. Many rely on ballooning, releasing threads of silk that catch the wind and carry them away. This instinct spreads the brood across landscapes, ensuring that even if many perish, others will find new environments to inhabit. It is a fragile beginning, but it sets the stage for the challenges to come. The molting stage, shedding for survival. The spiderling that emerges is delicate, encased in an exoskeleton that cannot grow with it. To continue developing, the spider must molt, shedding its old shell in a process that is both necessary and perilous. Pressure builds within the spider's body, cracking the hardened casing. Slowly, the spider pushes free, extracting each leg and joint until it emerges soft and pale, vulnerable, until its new exoskeleton hardens. Molting occurs multiple times, often 5 to 10 before maturity is reached. Each molt brings growth, physical changes, and sometimes the emergence of new colors or patterns. It also brings risk. A failed molt can trap the spider, leading to injury or death. Predators often strike when spiders are at their weakest, defenseless in their soft state. Yet molting also offers renewal. Lost limbs may be partially regenerated, and with each successful molt, the spider grows stronger, more capable, and closer to adulthood. The discarded shells left behind like hollow echoes mark the milestones of a life built on endurance. Adulthood, the life of a predator. When the final molt is complete, the spider reaches adulthood. Now fully grown, it no longer sheds its exoskeleton, but instead devotes its life to survival and reproduction. This stage reveals the extraordinary diversity of spider behavior. Orb weavers construct intricate webs, geometrically precise, designed to capture flying insects. Wolf spiders roam the ground, hunting with speed and keen eyesight. Trapdoor spiders conceal themselves within camouflage burrows, striking with sudden force. Fishing spiders use their hydrophobic legs to walk across water, detecting ripples that betray the presence of prey. Spitting spiders weaponize silk, projecting venom-laced threads from their mouths to immobilize victims. Silk remains central to adulthood. It secures prey lines, burrows, builds webs, protects eggs, and provides escape lines. Venom complements silk, paralyzing or dissolving prey so it can be consumed. Adult spiders feed on a wide range of creatures, from insects to small vertebrates, depending on their size and strength. Their hunting strategies, refined over millions of years, ensure that they remain among the most efficient predators of their scale. Adulthood also brings danger. Spiders themselves are prey for birds, reptiles, amphibians, and mammals. Parasitic wasps exploit them as hosts. Environmental changes threaten their habitats. Yet through adaptability, spiders endure, their presence felt in ecosystems worldwide. For males, adulthood is often brief. Their primary role is reproduction, and once achieved, their lives may end soon after. For females, adulthood can last years, especially in larger species like tarantulas, which may survive for decades. Reproduction and the continuation of the cycle. Reproduction is the culmination of the spider's life. Males risk everything to approach females, using courtship behaviors to signal their intentions. Vibrations, dances, and displays attempt to prevent fatal misunderstandings, but failure often means death. Even successful males may be consumed, their sacrifice providing nourishment for the female. Mating involves the transfer of sperm via specialized pedipalps, a process that requires precision and vulnerability. Once fertilized, the female begins crafting egg sacs, depositing her energy into the next generation. Some species guard their sacs, others abandon them, but in every case, the cycle is renewed. The survival of spiderlings is uncertain. Most will perish before reaching adulthood, victims of predators, starvation, or environmental pressures, but enough survive to carry forward the lineage. Through ballooning, dispersal, and relentless adaptation, spiders spread into new territories, colonizing habitats from forest floors to high mountain peaks. The act of reproduction is both an ending and a beginning. For many males, it is the conclusion of their lives. For females, it may mark the start of decline, or in some species, continued cycles of egg-laying. For the species as a whole, reproduction is the anchor that ties generations together, ensuring survival through the vast sweep of time. Conclusion. The unbroken thread of life. The life of a spider is a cycle of transformation and persistence. From the fragile egg sac to the peril of molting, from the mastery of adulthood to the risks of reproduction, Each stage reflects nature's relentless drive to adapt and endure. Spiders embody resilience. They are hunters, architects, guardians, and survivors. They regulate ecosystems, protect crops, and maintain balance in ways that often go unnoticed. Their silk stronger than steel by weight, and their diverse strategies for survival have fascinated scientists, inspired technologies, and challenged our perceptions of what it means to thrive in a hostile world. Though feared by many, spiders represent more than menace. They are reminders of the intricate connections that sustain life, of the cycles that begin in fragility and end in renewal. Their story is not only about individual survival, but about continuity, stretching unbroken from the depths of prehistoric time to the present and into the future. The spider's thread fine yet unyielding ties together the story of its kind. It is the story of persistence, adaptation, and the enduring rhythm of life itself.